Okay, this is the P4 paper from October 2021. It's question number 10, and we can see that this is a proof question, and more particular, a proof by contradiction question. Question number 10 is the last question in the paper, so normally they're quite difficult. I think with this one, it's the fact that it's proof, and there aren't many proof questions out there. Certainly this second part, have a look at what I do, and then you should be able to adapt that to any of the square root, cube root, whatever as we're going through. But let's make a start on it. So the first part, what they do is they give us this proof here, and it's just incomplete. Part of it's not quite done. So let's have a look and see what they're trying to do. They're saying, show that if n cubed is even, then n is even. So the way that I would have approached it is the way they've approached it. Say, okay, well, let's assume n cubed is even, but n is odd. And then hopefully I'll get some sort of contradiction. And if I get a contradiction, then we're well on the way to solving it. So if n is odd, then n is 2p plus 1. No problem with that. And n cubed would be 2p plus 1 cubed. So what we're assuming is that n cubed is going to work out to be even here. So this is going to be my contradiction in a minute. So what I need to do is start with my 8p cubed plus 12p squared plus 6p plus 1. And what I'm hoping then is that that's going to turn out to be an odd number rather than an even number. How do I show it's either odd or even? Well, in this case, I'm simply going to factorize that part there. So if I factorize that part there, quite clearly, I can take 2 out as a factor, which leaves me 2 lots of 4p cubed plus 6p squared plus 3p plus 1. So that is 2 lots of something plus 1. I don't care what the something is. That is now 2k plus 1, and 2k plus 1 is clearly odd, which is odd. So if I substitute all that in for here, then absolutely I've got my answer there. If we wanted just one line, I would go for that one or that one, but I think 2 lines would be fine for just showing exactly what we've done there. So that's completed that proof. Okay, part B. So this one says, hence prove by contradiction that the cube root of 2 is irrational. So if I'm doing one of those and trying to prove the cube root of 2 is irrational, I'll go through this method, almost, check this method a couple of times before the exam and just learn the sort of steps that you're going to do. What I'm going to do is I'm going to assume the opposite. I'm going to assume there are integers. I'm going to say P and Q such that P over Q is equal to the cube root of 2. Now what I need to do is to just add in the proviso where P over Q is a fraction in its simplest form. This is how we're going to get to do this one. In its simplest form, there must be a fraction, and you'd cancel it down. If it was 6 over 8, you'd call that 3/4. If it was anything where there was a factor in it, you would cancel it down. So I'm going to make that assumption there, and what I'm actually going to do is I'm going to show that P and Q both work out to be even, in which case it's not in its simplest form. That's the way to do it. So if we start off with that, if P over Q is equal to the cube root of 2, then obviously we need to get rid of the cube root sign here. So cube both sides. I'm going to get P cubed over Q cubed is equal to 2. And from that I can say, okay, P cubed is equal to 2Q cubed. Not easy to say. So if that's true, then P cubed is even. So therefore, P cubed is even because it's 2K. And if P cubed is even, so therefore P cubed is even, and so P is even. P cubed is even, then P has to be even as well. So I've showed that P is even. Okay, if P is even, P is equal to 2K. If P is equal to 2K, then P cubed can be written as 2k cubed. So p cubed can be written as 2q cubed. That's equal to 8k cubed there. So p cubed is equal to 2q cubed, which is equal to 8k cubed. So that should be outside like that, obviously. And so if that's true, then q cubed is equal to 4k cubed. And if it's 4k cubed, then q cubed is also even. And so if q cubed is even, then q is even. And I've now got the situation where I've shown that p and q are both even. If p and q are both even, then it's not a fraction in its simplest form. So there's my contradiction. So my proof, my original assumption is false, and so the cube root is not rational, it's irrational. Let's write all that down then. So if p and q, if p and q are both even, then fraction is not in simplest form. So that means there's a contradiction, so I'm going to make this really clear. Therefore, there is a contradiction. And it's as many of these lines as you want to put in here. I'm going to give absolutely everything because I don't like proofs. Therefore, it's a contradiction. Therefore, my original assumption is false, and so the opposite is true. Therefore, cube root of 2 is not rational. Or actually, let's use the correct terminology, is irrational. Right, so that's my interpretation of a proof question there. I think that'll do. Obviously, go and check the examiner's reports for everything. Every single time there's a proof question, make sure you've checked the examiner's reports just to see that you've included everything. Hopefully that all makes sense.